Hi, I welcome you back on the new topic, which is inductive effect and the resonance effect. This is in continuation with the previous topic that we have just studied. The topic was effect of substituent on reactivity, and we have seen that there are some substituent which increases the rate of reaction of benzene, while there are some substituents which decreases the rate of the reaction. So in this topic that we are going to cover today, we are going to see the basis of such phenomena, that how can a small group can increase or decrease the rate of the reaction. So the basis of such influence are two effects with the name inductive effect and the resonance effect. Now you can see the image below containing two types of dipoles. Here are the positive dipoles, which shows that these are the groups which are donating the electron density to the benzene ring. On the other hand, there is red dipole, which says that the group is pulling away the electron density from the benzene ring. So such type of groups are called activating groups, and these are the groups which are called deactivating groups. This activation and deactivation can occur through these two effects, inductive effect and the resonance effect. Now the other name for resonance effect is mesomeric effect. So we will see the subtypes of both of these effects. Inductive effect can exist in the form of plus I and the minus I. Plus I means inductively donation of electrons. If any group is donating electrons through the inductive effect, that effect would be considered as plus I. We are going to add plus sign in front of the I, so that becomes plus I effect. If any group is pulling the electron density, that means it is doing inductive withdrawal, then this effect would be considered as negative inductive effect. The same goes with resonance effect. It can exist as plus R and the minus R. Plus R would mean donation of electron density through resonance, and the negative R would mean withdrawal of electron density through resonance. So let us first see inductive effect in detail. Inductive effect works through the electrons of the sigma bond. The basis of the inductive effect is the push and pull of electrons through the sigma bond. This sigma bond term is very important here. You can very well understand this thing through this tug of war example. As you have must seen this game, there are two teams which are pulling the rope in their direction. So suppose this team wins in the end. So with the pull of this team is going to cross the line, and how the full effect of this team is transferred over its opponent is through the rope, because they are pulling the rope and rope is connected to this particular team, and they are going to get pulled towards the center point. So pay attention to this thing, that the pull is happening through the rope. Similarly, in the inductive effect, the push and the pull happens through sigma bond electrons. Let us see in the terms of chemistry. Suppose there is a group which is more electronegative than the carbon. So this electronegative atom would be considered as partial negative, and the carbon in its adjacence would be considered as electropositive, because this electronegative carbon would be pulling electron density from this carbon towards itself. I hope it is clear to you. Now this electropositive carbon is going to pull the electron density from the next carbon. So this carbon will also become partial positive. The effect will continue to the whole molecule, and its magnitude will get reduced as we move far from this particular atom. So the more far we will go, this effect will fade away. But I hope you can understand that it is working through the sigma bond electrons, because this bond got polarized and this carbon became partial positive. This carbon now pulled some of its electron density, and this carbon also became partial positive, and the effect will fade away as we move far from this particular atom or group. So negative inductive effect is exerted by the groups which are more electronegative as compared to the carbon. So the example of such groups are halogen atoms, hydroxy, NH2, COOH. All of these atoms or the groups are more electronegative as compared to the benzene carbon. So that is why when they are attached with benzene, they will pull away the electron density and they will exert negative inductive effect. Now let us move on to the positive inductive effect. In this case, the atom which is attached or the group which is attached is going to be electropositive, and it is going to donate electron density to the adjacent carbon. So this carbon will become partial negative, and this carbon will further donate some of its electron density to the next carbon, and it will also become partial negative, and the effect will fade away when we move far from the group. So the examples of such groups are CS3, CS2 with more alkyl groups, and then there are some more alkyl groups, and then there is COO negative. So all of these carbon can donate electron density to the benzene ring. So that is how they are exerting positive inductive effect, and the characteristic of inductive effect is that the electron density is provided through the sigma electrons. Now you will see the example of COOH in the negative inductive effect, and you will see COO negative in positive inductive effect. Because now it has negative charge, so negative charge group can donate its negative charge to the benzene ring. So that is how it is going to increase the electron density of the benzene ring. So COO negative is in positive inductive effect, and COOH is in negative inductive effect. Okay. Now let us see the other effect, which is resonance effect, and in this case the effect is transferred through the lone pair electrons and the pi electrons. Let us see how. Suppose there is conjugation in the molecule, and on the other end of the conjugation there is one electronegative atom. So what it can do, through the pi electrons, it is going to pull electron density on itself. So there must be conjugation and one electronegative atom. So the effect that would be there would be negative mesomeric effect. You can also call it negative resonance effect. So I hope you have understood the key difference between the inductive effect and the resonance effect, that inductive effect works through sigma bond electrons and the resonance effect works through lone pair electrons or the pi electrons. So similarly, if the COOH group is there, so what it can do, it can pull the pi electron of the benzene through the conjugation and finally on the electronegative atom, which is oxygen. So COOH can exert negative inductive effect and the negative mesomeric effect. So the same group is exerting its effect through two different modes, which are negative inductive effect and the negative mesomeric effect. Let us see how positive mesomeric effect would work. Suppose there is a group which has lone pair of electrons, then it can donate its lone pair of electrons into the pi conjugation of the molecule. So that is how it can release electron density through the pi electrons. So suppose there is a group which is attached on benzene. Like this oxygen, it has lone pair of electrons. It can donate its lone pair electrons into the benzene ring. So that is how it can increase the electron density of the benzene ring. Now hydroxy, we have seen it exert negative inductive effect, but it can exert positive mesomeric effect. So such combinations are possible. There can be groups which can induce positive inductive effect and the positive mesomeric effect. There can be groups which can induce negative inductive effect but positive mesomeric effect. So different combinations are possible. There is nothing to get confused about it. It all depends how the molecule interacts with the benzene ring through the sigma bond electrons and the pi bond electrons. So the net effect, whether the molecule is going to increase the electron density of benzene or is it going to decrease, will depend upon the net effect of the combination of two effects. So the effects are going to get combined. The effect of the inductive effect and the resonance effect are going to get combined, and the net result would be there. And usually it is seen that the mesomeric effect is usually stronger than the inductive effect. So hydroxy group, I know that it is negative inductive effect but positive mesomeric effect, but the net effect would be based on the positive mesomeric effects. The hydroxy group is going to be electron donating. It is going to be activating group. That is why in the example we have seen that the hydroxy was increasing the rate of the reaction because it was inducing positive mesomeric effect, although some negative inductive effect was there, but the net effect was electron releasing. So it was activating the benzene ring towards electrophilic substitution reaction. I hope all these things are clear to you, that how a group exert effect on reactivity of benzene, how there are two different effects which are the basis of this electron donation and withdrawal. I have explained to you the positive and the negative inductive effect with the examples, the positive resonance effect and the negative resonance effect with examples. If question comes on any of these topics, I'm sure you will be able to handle it. Theory of reactivity is nothing but understanding how the substituent exert effect through electron donation or withdrawal and affects the rate of the reaction of benzene is nothing but the theory of reactivity. So this is the definition thing for it. I hope it is clear. The electron donating groups are going to increase the rate of the reaction and the electron withdrawing groups are going to decrease the rate of the reaction. So that is all. With this we have finished the topic effect of substituent on reactivity. In the next session we are going to start a topic which is effect of substituent on orientation. So see you in the next session.